Learning how to land can be one of the most challenging parts of learning how to fly. And rightly so, it can feel complicated. There's a million things most instructors are telling their students to look at as they're coming into land. Get your speed on, get on centerline, look long, don't pull too hard. Okay, go ahead and pull now, right? There's a million things happening at once. But if a million things are happening at once, it's going to feel like an art form or magic. We need to remove those variables first, then landing feels easy. Today we're going to take the Luscombe up and do a bunch of patterns and look at how to remove those variables so that the only thing left is smoothly and slowly pulling back on the stick. Once we get to that point, landings will be easier. Let's get started.
All right, everyone, we got the Luscombe running. NOTAMs are checked, run-up's complete, and it's been a long day, but we got about 45 minutes before sunset, so we're going to get to it. A little overcast tonight, so might get dark a little early, so this might be a short lesson, but who knows. Wahoo traffic, Luscombe 903 is departing runway 20, left closed traffic, Wahoo. Okay, got that done. We got a left crosswind here and at altitude. The winds are identical, both here on the surface and at 3,000 feet. So that's nice and consistent. All right, we're lined up with 20. We got a little aileron to the left, bringing in the power. Carb heat is in, power, oil pressure, oil temperature, speed's alive, tail's coming up. Come up off the left wheel first with the left crosswind. Coordinate 65. And head on a swivel. I think most of the crop dusters are done for the day. All their hangars are closed, so that's a good sign. Okay, so today we're talking about landings. Now, I assume if you're watching this video, you watched my previous video about approaches, because it doesn't matter what technique, how many times, or how many lessons you've had, if your approaches are not consistent and solid, and your go-arounds aren't fluid and confident, then there's no point learning how to land, right? Perfect example, I had a student I was working with here in the Luscombe, and we were out doing air work, you know, we were getting into the pattern, low approaches like we talked about in the last video, and then I sent him over to the local flight school to get checked out in the 172 and solo over there. Let's see, clear left, turning left, got a point picked out. And so I sent him over there, and the instructor did not take him out and, you know, do stalls and air work and all that stuff. You know, he'd never really used flaps before, and he just tried to beat the procedure into his poor kid's head and try to beat landings into him without any familiarity in the airplane, and it just didn't work, right? So that's kind of the worst case. But, you know, if you're struggling with landings, look backwards. Look at the approach. Look at the takeoff. Look at your planning, right? Because those things matter more than landing technique itself until you get to that point. Okay, clear left, turning left. Wahoo traffic, Luscombe 903s, turning left downwind, 20, touch and go Wahoo. Okay, now we're flying a tail dragger today, and we're going to do what we call 3-point landings. And so this applies to everyone, whether you're flying a tail dragger or you're flying a nose wheel, Cessna 172 or something like that. This is universally applicable, right? So we'll save the wheel landings for another time. But anyone should be able to get something out of this video. And back to the previous point about that student, I would say one of the most important things that you can do to be comfortable to prepare for the landing itself is to be comfortable with stalls. If you're not comfortable with stalls, good luck trying to land, right? Because a stall or a landing is an approach to a stall 2 feet off the runway. And if you're not comfortable with that at 5,000 feet, good luck to you at low altitude, right off the runway, right? There's the numbers. Carb heat, power's coming out. So what I like to do is go out and do lots of stalls, right? And I'll just go up, climb up, pull the airplane into a stall, ease the stick forward, and then pull back into another one, right? We complicate it with procedure and power and climb away this and climb away that. But the whole point, or not the whole point, but half the point in the pre-solo phase is to just be comfortable with the airplane in the stall. And if you doctor it up with procedure, you know, you're not going to get the feel of it. All right, we're on base. Wahoo traffic, Luscombe 903s, left base 20 Wahoo. Okay, looking down my final. Okay, so what I'm looking for here for the very first thing, like I've been talking about, is that our approach is consistent, our pattern is consistent, and so my goal is to deliver the airplane to the threshold at idle, at 65 knots, at the exact same height every single time. And centered. We'll talk about centered here in a minute. So I'm high, and I'm going to slip. I got a nice stable atmosphere. I've got a left crosswind. The temperature is average, so most everything's working in my favor here in terms of energy. And so, you know, you kind of got to think about those ahead of time. Now I slipped maybe just a skosh too much, but we're on final. Wahoo traffic, Luscombe 903, short final, 20 Wahoo. Okay, let's see here. We should be able to make it to the runway. Oh, I'm going to have to put power in. Shame on me. Okay, now idle and a little bit of pull. There we go. We're centered. Carb heat, trim. Well, we'll talk about that in a second. Here we go. Let's go. Tail's coming up. Oil pressure, oil temperature in the green. 55, rotate. Right, in the last video, we talked about how important the first power off approach is. And if you don't get that, then, right, your power off approach method's probably not quite ready for an emergency. And I just came up just a hair short there. I still made the field, but wasn't quite going to make the runway. So I destabilized the approach at the end. And that just worked against everything that I was talking about, right? So we need a little more energy the next time around. So there's that. So we talked about the importance of stalls, right? And that's really what a landing is, right? If you think you can land in any airplane other than a tail wheel doing wheel landings, right? So any landing you do with that fast, you're mistaken, right? You should not be landing fast. Why? Because speed correlates into pitch attitude, right? There's no way to land fast with the nose up. There just isn't, right? Because if you're fast, you're going to have the nose down. Wahoo traffic, Luscombe 903 is left crosswind 20 Wahoo. Right? So we have to get slow. And you might not get all the way to the brake, right, like you might in the stall out in the practice area, but you're going to get awful close if you do it right, right? And so I like to walk people through the evolution of how we got to nose wheel airplanes. And it went very simply as this in terms of Cessnas that we're most familiar with, right? Clear left, turn and left. Okay? It went like this. A guy named Luscombe, Don Luscombe, designed the Luscombe. Clyde Cessna wanted to get into the metal airplane business, and he bought some Luscombes. He figured out how they were built, and he made the Cessna 140. Once he did that, he made the Cessna 170, which is a tail dragger, and then he decided to put a nose wheel on it, and that became the Cessna 172. So as I like to joke, everyone flying around in a 172 is flying a cheap copy of a Luscombe. But anywho, the problem is that they mounted the nose wheel on the firewall, right? And if you've spent enough time around flight schools, you know that one of the biggest issues is dented in firewalls from hard landings on the nose wheel, right? And so it's weak. Don Luscombe never designed the firewall on a Luscombe to handle the stress of a nose wheel, right? But then Cessna did it. And as we all know, Cessnas, single-engine Cessnas, are notorious for weak nose wheels, right? All right, looking at the glide here, turning left. Wahoo traffic, Luscombe 903 is left base, 20 Wahoo. Okay, so, and then from an engineering perspective, if we think about it, the engineers design the main gear, the main wheels, for the impact of landing. The nose wheel is just there to hold the airplane, right? It's not designed for landing loads. And so if we're coming in fast and landing on the nose wheel, even if we're just skipping off of it gently, that's not good for it, right? That's not what it was designed for, right? It is designed to hold the airplane at the right attitude. It's not designed to handle impact energy. So we need to put the airplanes on the main gear, and to do that we need to arrive in a nose-high attitude, slow, so that's the point of practicing stalls. All right, I got a little more energy this time. Low traffic 903, short final 20, Wahoo. Okay, we're feeling it out, keeping my speed, looking a lot better now. Oh yeah, we'll make the runway this time. Okay, so we're coming in straight, little crooked off to the left, nose up, and touchdown. There we go. Stick all the way back, carb cold, reset the trim, keep her straight with the feet. Trim's reset, power's coming in, oil pressure's in the green, tail's coming up. Airspeed's alive, little crosswind yet from the left, there we go. And we are airborne, as John and Martha King would say. Okay, so we've talked enough about stalls, right? And we've talked about how we need to deliver the airplane to the runway on speed, on height, centered. Now, the next thing to talk about is the centeredness part itself, right? And man,
4 miles north of field, up to straight in runway 16.
Okay, not Wahoo. By the traffic, Luscombe 903 is on the go, 20 Wahoo. Okay, the next thing to do is to talk about alignment, because lateral alignment, side to side. If I had a nickel for every single time a student landed left of center, I would be wealthy. I'm dead serious, right? Because, you know, I've been flight instructing for almost 10 years now. I would guess that I've been in the airplane for 10,000 landings, would probably be a good guess with students. And yeah, if I had a nickel for every landing left to center, I would have a lot of money, right? Why? Because the pilot sits on the left side, and when we drive our cars, we intentionally offset ourselves to the left, right? And we do the same thing in airplanes, especially when we're sitting on the left side, because we're looking across the nose incorrectly. Whereas instead, I like to put my hands together and straight out, right? And whatever's straight out in front of me, that's where I want to point the nose, right? And so, as instructors, we need to be working real hard to help our students get to the center line. And when I say that, here just a second. Wahoo traffic, Luscombe 903, left downwind 20 Wahoo. I don't mean at touchdown, I mean on final. And the problem is most people approach from the left side. I call it the left side funnel, where we're coming in from the left and we're working to the right. And the problem is if you're not dead nuts lined up straight, well, now you have to take cognitive bandwidth to handle that alignment problem as you come in. And then that also destabilizes the approach, right? Because now you're having to turn right, you're introducing a turn, you're introducing yaw, maybe even adverse yaw if you're not coordinated, and it just gets messy, right? So I like to look at the center line of the runway, the left side of the runway, and the right side, and I want the left and right side to be parallel, and I want the center line to be just straight out in front of me. And I'll put myself on a little bit longer final this time. And so one of the ways that landings get better is that we are aligned sooner, right? So I tell my students, imagine you're landing on an aircraft carrier, and you have to, let me turn base. Wahoo traffic, Luscombe 903 is left base 20 Wahoo. All right, imagine you're landing on an aircraft carrier and you can only be 1 foot left or right of center. You would be worried about center line alignment a whole lot more than if you're landing on a 200-foot wide runway, right? So we really got to think about that alignment as well as our up and down, right? Our energy state as we turn final. We got to be thinking about both, and we need to be thinking about that alignment with a better precision. Okay, turn it final. Got you a little straighter final here, and we can look at it this time. Wahoo traffic, Luscombe 903's final 20, touch and go Wahoo. Okay, I'm going to intentionally roll out on the left side of the runway, and we see what the runway looks like off to the left. Now we come over to the right side. Right, that doesn't look good. So we come back over to center. Okay. Now I'm really high, so I'm going to slip. But even when I'm slipping, I can still turn the airplane side to side, right? I just happen to have the rudder down. Okay, now we're lined up on center. I'm looking down that center line. It's good and straight. I'm a hair slow, so I let the nose down just a little bit. I want to arrive right over the end of the runway. And then I look long down the runway, ease back on the stick, pull, 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 pull. There we go. And we're down. Okay, carb heat comes off. Trim. Bring in the power. Oil pressure, oil temperature, 55, rotate. Okay, next thing to talk about, arriving at the runway, is the power itself. Okay, and I understand that most people do not fly power on off approaches like I'm doing now. I made the case for that in the last video, and I won't belabor that here. I think you should consider it if you're flying single engine airplanes during the day. But let's say you're not, right? And I see this at work all the time in the King Air and the jet. And that is, when do you get rid of the power? And more importantly, when do you get rid of the power? Or I already said that. How do you carry power into the landing? Do you carry it over the runway? Do you pull it out quickly? Do you pull it out slowly? Well, here's my thoughts on it. First thing is, power needs to come out slowly, right? We need to take time to reduce the power. If we're reducing it over the runway or in the final parts of the approach, we need to reduce it gently. Why? Because it's destabilizing the airplane. Right? If I take out power in this, the nose is going to drop, and then I'm going to have to pull back, and that'll probably slow us down a little bit. And it just destabilizes things. And the quicker you yank that power out, it just adds another issue that we have to deal with down low. And so, you know, start 3 or 4 seconds early and pull it slowly. And most importantly, on most piston engine airplanes with a throttle plate, you want to pull the last half off extra slow. You can pull the first half out pretty quickly, right? I just pulled the first half out here on downwind, or turning downwind. Low traffic, Luscombe 903 is turning left downwind, 20 Wahoo. Okay, you can pull the first half out pretty quickly because you're not tipping the throttle plate much in terms of the degrees near closed. But the last half of the throttle makes a big difference, and you want to pull that out early and slow. That allows you to handle any pitch effects that the power causes, okay? So there's that. Then also, I'm a firm believer that you should never carry power into the landing itself, unless you're doing a soft field and then you're adding power back in. But especially for learning how to land, get rid of the power. Why? Because it's one more variable messing with you, right? And so we want to turn landing into a stick and pitch problem, not a stick and pitch and power problem, right? Okay, now here's the numbers, carb heat. Now I pull that last half of the throttle off real slow, and I had to pull back a little bit to maintain my attitude. Then the airplane slows down by me pulling back on it. That allows me to head for glide speed. I got the trim set, and now I can start looking off my shoulder for when I'm going to turn. I know the wind's carrying me in towards the runway, and I'm 65, turning base. Low traffic, Luscombe 903 is space 20 Wahoo. Okay, so best thing you can do is get rid of the power. Why? Because the power is causing you to keep the nose down longer, right? And it's carrying speed, and what we want to do is come over the runway, lose our speed, and land. We do not want to belabor the problem. And the longer we belabor the problem, the more chance that it's going to go south, right? So people say, oh, I like to carry power in on gusty crosswind days. Well, you're just delaying the inevitable, right? And, you know, I think that if you're properly trained, you can do it without power. Low traffic, Luscombe 903's final 20, touch and go Wahoo. Okay, power's at idle, right? So that's one less variable I have to think about. Literally, the only thing I have to think about now is pulling back on the stick. That's the only thing I got to worry about. 65, all right, we're coming in. 60, a little slow. Okay, a little left to center, working right. And now looking long down the runway. Pull. Ooh, little bounce. Hold it back. Not the prettiest. Okay, carb heat. Reset the trim. Power set, oil pressure, oil temperature into green, tail's coming up, airspeed's alive. Still a little left crosswind, rotate. Okay, so hopefully we're arriving over the concrete, centered, on speed, on height, power smoothly at idle.
Traffic air check, kick off deals, turning left base, final, 15 Brest City.
And that then brings up the question of what makes good landings. And I'm convinced that good landings specifically come from an undisturbed airplane, right? An airplane that is in its flight condition, it's stable, it's not rocking around, it's not pitching a bunch, it's just there, right? And that the pilot is messing with the controls the least. That is how you get smooth landings, right? Because even just a little twitches side to side will give that wheel a hard impact. And so if you're chasing those smooth landings, which you might be if you're working past, initial solo or you've been flying for a while. But even at solo level, right, it's very important that we're messing with the airplane as little as possible.
Wahoo traffic, Luscombe 903, left crosswind, 20 Wahoo.
Okay, we want to be messing with the airplane as little as possible and just have it stable and smooth and just there. Okay, and if we can calmly bring it in, then we have a better chance of making smooth, predictable landings. Not even smooth, but just predictable, right? And so, it's kind of interesting watching students evolve in their training.
Wahoo traffic, Luscombe 903, left downwind 20 Wahoo.
It's interesting watching them evolve in their training because it's like things are chaotic and then their own chaos makes things worse. And then over time, it's still chaotic, but they're not making things worse. And then they start getting better, and then that getting better compounds, and then all of a sudden they're able to fix their own mistakes. And what was throwing them for a loop before now becomes easy because they have less problems to solve, so they have more time to spend on doing well, right? And that just gets better and better and better. And I see that with landings a lot. And so it's kind of like things get better all of a sudden because it's like all of a sudden they're not fighting themselves. And now we can deliver that airplane smoothly and stably and on speed, on height, centered, and with stable power. Okay, so here comes the numbers, carb heat. Now let's talk about where to look in the landing, right? And I really like what's called the runway expansion effect. And maybe I'll put some graphics up here. Imagine you're sitting over a runway 10,000 feet up, right? It's this tiny, tiny, tiny little strip. And then imagine you're an ant crawling over the surface of the runway down the center line.
Wahoo traffic, Luscombe 903, left base 20 Wahoo.
You're this little ant, and now you can't even see the edges of the runway because they're so far away, right? And so as we come into land and as we get lower, 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 that width of the runway expands rapidly from very narrow to very wide. And that is one of our biggest clues for telling us how high we are over the runway. And your instructor will help you correlate how high you are if they're doing a good job of teaching you what to look for. But we learn that best by looking to the long end of the runway and letting our peripheral vision see that expansion effect.
Wahoo traffic, Luscombe 903's final, 20, touch and go, Wahoo.
Okay, hair left of center, working to the right. Okay, speed's a hair fast. And I've come up just kind of on the shorter side of things, so I'm going to quit slipping early. Maybe a hair right of center, coming into speed. We've been getting a lot of sink here at the end. Yeah, there it is. There's a reason for that. We might talk about that if we have time. Okay, idle, looking long down the runway. Runway's getting wider, 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 and we're down. Okay, carb heat, trim. Okay, so everything we've been talking about is preparing for landing. Get the power in, tail's coming up, carb heat. Temperature, good, 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 good. 55, rotate. Hey, everything we've talked about so far is really more about preparing to land than landing itself, right? So let's talk about what an ideal landing would actually be. And it's cool, I've actually looked into this in the physics and have done some simulations, some computer simulations of landing physics. And it's actually really fascinating in that if we look at the stick, what input do we have to make to fly a nice smooth path down to land with the nose in the right attitude and all this sort of stuff? What it looks like, if we're getting rid of the power early enough, is it looks like just one slow, smooth pull on the stick. Okay? And what you specifically do not see is forward stick inputs, right? Pushing forward on the stick, right? It's just back pressure. And so good landings come from a method that I call the stuck ratchet method, right? Okay, we're clear left, turn left. Imagine that you're trying to get a nut off of a bolt, you know, like let's say you're trying to get a lug nut off your tire, and it's just stuck, right? It will not come off, right? And you're using a ratchet, right? So you strain against it and nothing happens, and then you pull it back and click, 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 right? And then you try again, and it doesn't go anywhere, and click, 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 right? The ratchet only would go one way in that analogy, right? And the same applies in landing. Clear left, turn left.
Light traffic, Luscombe 903s, turn left downwind 20 Wahoo.
Okay, the same applies in landing. We should be slowly and smoothly pulling the stick back. Okay, now it starts really slow because we have a lot of kinetic energy, and if we pull too fast, we're going to trade that kinetic energy for potential. As we get slower, that kinetic energy has less ability to create height, and we'll look at that in an energy management video here soon, which I'm really looking forward to doing. And so the slower we go, the less chance we have of ballooning, right? But early on, if we pull too much, we'll balloon, right? And so here's my deal with balloons. If you balloon, you stop pulling on the stick and you freeze it in place. And then one of two things will happen. Either the airplane will come smoothly through the balloon and you can continue pulling again to land, or you're going to have the itch to push. And if you have any itch to push on the stick at all, go around. Boom. That's your clue.
Wahoo traffic, Luscombe 903s, left base 20 Wahoo.
Right? Nobody would do pilot-induced oscillations down the runway if in a balloon they felt the urge to push forward and did a go-around. You would not be in the position where you're pushing down and you're putting the nose down where you're going to strike that nose wheel and set up a PIO, right?
Wahoo traffic, Luscombe 903 is final, 20, touch and go Wahoo.
So I tell my students, if you have the urge to push, or I catch you pushing, we're going. No questions asked, no debate, no riding it out. If you push forward, that's when we go around, right? So it should be just one smooth, steady pull on the stick. Okay, now we're coming in here, got a little burble there. Coming into 65, power's at idle. Now, just watch the stick if you can in the video here, and you're just going to see that it's going to be one smooth, slow, 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 and fast pull on the stick. Right? It was just one steady travel aft. And now, when I'm down, I pin it back. I don't let it forward. Right? I hold it back, hold it back. Okay, carburetor heats cold, reset the trim, stick back, full power. Now I can ease forward on the stick a little bit. Fuel pressure or oil pressure and temperatures in the green, tails coming up. Airspeed 55, rotate. Set up my crab for the left crosswind. Okay, so now let's think about it from a physics standpoint. What happens when we smoothly pull on the stick at idle versus pushing forward? Well, if we smoothly and steadily are just pulling gently back on the stick and pausing, you know, if let's say you're coming in and you pull back and it starts coming up a little too much, or you know, you feel like you're slowing, you just stop pulling, you know, just hold it, wait, and then you feel the airplane sigh and start coming back down again, then you start pulling again. And so what you're doing is what I would call lift maintenance, right? By pulling back on the stick, the airplane is slowing down and increasing angle of attack, right? And despite slowing down, that slow, steady pull on the tip.
Atlantic traffic, San November 512 Papa Golf, transiting from the northeast to the southwest, 2,600 Atlantic.
That slow pull on the stick is keeping lift equal to weight, roughly. If we push forward on the stick,
Wahoo traffic, Luscombe 903, left crosswind 20 Wahoo.
if we push forward on the stick, we're telling the airplane, oh, we don't need as much lift as we do weight, right? So maybe your airplane, I don't know, this weighs, 1,200 pounds right now, maybe. And you push forward, all right? Now you're saying, oh, I just need 1,100 pounds. I don't need 1,200.
Who's up there enjoying this beautiful weather at Wahoo?
Oh, Dave's here. We're turning left downwind 20 Wahoo.
Don't know who that is. Okay, so you go and push forward on the stick. Now the airplane's going to do a swan dive, right? And then you're going to pull back to save that, right? And so you do not want to be pushing forward on the stick. Like I said, if you push forward, go around. It's that simple. Okay, so now it starts slow, right? We talked about that, and then it finishes fast. And why is that? Well, it's because our kinetic energy is low, which is good, but even better, our drag is getting high, right? Because we're coming into the back side of the power curve. And so when we do that, that last little pull, right at the last minute there, the drag just goes through the roof, the kinetic energy is low, and the airplane just goes, and it lands, right? If we do it too early.
Atlantic traffic, Champ 2 Bravo Golf will be transiting on the north edge of the runway. Should be no factor for your departure, Atlantic.
Idle, trim. Right, you do that too early, the airplane's still got pep in its step, right? And it hasn't got all of its induced drag yet, right? And then it's like, whoa, here we go, right? So we do not want to do that. Okay, clear left, turn left.
Wahoo traffic, Luscombe 903s, left base 20 Wahoo.
All right, it's getting darker. Hopefully the video is still good here. Let's check our time. We still got 15 minutes before sunset. All right, and we're a no electric antique airplane with no position lights, so we got to be on the ground by sunset. I called the base. All right, I'm in a little tight. I'm turning right just a hair. Okay, and turn it final.
Wahoo traffic, Luscombe 903s, final 20, touch and go, Wahoo.
Okay, so I'm going to show you I'm going to intentionally come in high, okay? I'm going to probably aim for like the 1,000 footers here, and I'm going to demonstrate what I just talked about with the urge to push forward. I'm going to pull back too early, and then I'm going to push forward, and then I'm going to get out of town to show you why, hey, we don't do this, okay? So we're coming in. Maybe we add some power, right? We got power in here, and the power's messing with things. Then we yank the power out, and then I got to pull back on the stick. I'm exaggerating a little bit. Okay, so we come in here, and we're coming in for the descent, and then we shift to look long, and then we pull too early, and the airplane goes back up, and we push forward, and it's like, no, let's get out of town. Carb heat, cold, trim is reset, oil pressure, oil temperature's in the green, up we go. Right, maybe a little exaggerated, but you get the gist, right? That is not a good place to be, right? We need to be stable and smooth and under control, and just smoothly pulling back on the stick for the landing. Okay, so let me look at my list here. Yep, we talked about that, Okay, we talked about that, yep. All right, we're doing pretty good. Let's talk about the landing itself, right? So, everyone gets all hung up on smooth landings, and I like chasing smooth landings. I love coming out here and just doing patterns in the evening. Who doesn't, But as a student pilot, you shouldn't be chasing them. Now, you don't want hard landings, but if you have consistent, firm, nose-high landings, then good enough for government work, right? And literally, So don't stress about getting perfectly smooth landings, and then don't add speed and power to try and come in and grease it on in a nose-low attitude. You're just setting yourself up for a pilot-induced oscillation, right? And something very expensive, right? So, you know, if you want to come in fast and flat, buy a tail wheel. Then you can do wheel landings, right? I love doing wheel landings. In fact, this is probably the most number of three-point landings that I've done in the Luscombe in one flight in a long time, maybe even ever.
Traffic, tractor 9, Juliet Bravo, 5 to the south, inbound runway 2, Norfolk.
Flight traffic, Luscombe 903's left downwind 20 Wahoo.
Okay, so what was I just talking about? I forgot. Ha! Oh yeah, coming in fast and flat. Don't do it. Speed is not your friend in the landing, right? You need to get rid of the speed. There's no such thing as a good fast landing in a nose wheel airplane or in a tail wheel airplane doing a three-point. There just isn't. You got to come in, get low, get rid of the speed, and then land, right? Okay, so here comes the numbers: carb heat, idle. Let me kind of talk through some of the sensations I'm going through on these in terms of when I can pull, and I'll try and talk through that as we go. Okay, so we're going to turn base now.
Wahoo traffic, Luscombe 903's left base 20 Wahoo.
Okay, and then once we land, I'll talk about something that's important. Okay, we're coming around. Base is looking good. Final's looking clear. A little fast. But I'm liking my energy, right? As you see, I love to slip, right? A slip is such a useful tool. It lets you just tailor the approach beautifully to be right where you want to be. Okay, so I'm going to intentionally be long on this one because I want to have time to talk through this. And I'm going to come in a little fast and show you what I'm getting at by waiting to sigh, right? Waiting to let the airplane tell you when it's ready to land. Okay, so I'm coming in, and the bottom's falling out here just a little bit at the end, but I think we're in good shape. Okay, so we're coming in, and I shift to looking long, okay, straight, and I'm pulling, and I felt it jump a little bit there. And then I wait for it to descend, and there, so it starts to descend. I felt it drop a little bit, and then that's my cue, pull, right? So if you're just smooth hanging out over the runway, and then you feel it start to sink, that's your cue. Hey, go ahead and pull, right? That's a good sign. Okay, now, the other big thing to talk about is what we're in right now. We've got the stick back, and I am still flying the airplane. The airplane happens to be on the ground, but the wheels are not supporting all of the weight. Right? Okay, I'm going to put the power in. And so I remember my granddad. My granddad was a private pilot. He got his private pilot's license, I think in 1954 or 55. And I remember this story he told me before I ever started learning how to fly. He was out flying in a rocket champ. He came in and landed, and then a gust sucked him back into the air, right? And you know, he poured the coals to it, got out of town, and came around again. And, you know, that was an interesting story. I didn't really understand exactly what he was getting at until I started to fly and, you know, going on a couple years and feeling things out, and then started flying tail draggers, yada, yada, yada. And what I realized is that a lot of people land and then assume, oh, the airplane's on the ground. It's a land vehicle again. Absolutely not. No. Right? Until you tie it down, you are still an airplane, right? And so, you know, and just because the wheels are on the ground right after touchdown does not mean that you could get sucked back up into the air again. And so what I like to do for students who demonstrate, or for students who come in fast and flat, is I will take the controls right as they touch down.
Wire traffic, Luscombe 903's left crosswind 20 Wahoo.
And I will suck the airplane back up into the air again. I'll just rip back on the yoke. This is a 172. Don't do this unless you know what you're doing, right? You're probably a flight instructor. You've seen a couple thousand landings. But, you know, it's amazing people come in and land and it's like, oh, the wheels are on the ground, we must be done flying. Absolutely not, right? There's still enough airspeed and energy to suck the airplane back up in the air and get another foot or two of altitude out of it, right? And the airplane will happily take off again and then land again. And so that's just a proof to show, hey, you landed fast, you landed flat, the airplane was not done flying, right? And as the old joke goes with Luscombe's, you're not done flying till you flip it on its back and drive stakes through the wings, right? So, I prefer to put it in a hangar rather than flip it on its back and drive stakes through the wings. But anyhow, yeah, you got to get it down, get that stick back, and that's why we hold that stick back. And we keep it back after we land because we're holding it down there with, you know, lots of drag, high angle of attack, and we should be out of energy, and that should help keep us on the ground. But we're not done flying until we're actually done. Okay, I think it's time to call it a night. There's the runway. Maybe I'll demonstrate that. I'll come in a little fast, like we would in a wheel landing, and then I'll pull it back in the air and show you that, hey, just because the wheels are on the ground, the airplane's still flying. And if that stays stable, then we will call it a night. If not, we'll get out of town, right? Because that's what go-arounds are for. Okay.
Wahoo traffic, Luscombe 903's left base, 20 Wahoo.
Little note, I like to get around this downwind to base turn as quick as possible, right? Because I want to be able to look at the runway and see my energy, right? See how my glide is. And if you baby that turn, especially if you got a tailwind carrying us in this kind of situation, then it just delays getting a good energy read on the situation here. So we're 70 and we're pretty good. I don't think I'm going to slip too much, at least not here early on final. Slipping around the turn a little bit.
Wahoo traffic, Luscombe 903's final, 20, full stop, baby, Wahoo.
Okay. All right, so I'm going to come in at 70. Right, and that's another thing, right? You don't lie to yourself on final with a high speed, right? If your approach speed is 65, stay on 65. If it's 70, it's 70. Whatever it is, stick to it, right? Because I'm 5 knots fast. If I pull to slow down to get to my normal glide speed, it's like, oh, my aim point just shifted, right? I'll put the nose back down to get to 70. But, yeah, don't lie to yourself by flying the wrong speed. Your energy has to be both altitude and airspeed. Okay, so we're coming in, and I'm going to land a little flat like I would in a wheel landing. And then, look, I can pull it back in the air again. Whee! And there we get a second landing out of it, right? So that's what you do not want to have happen. You do not want to land and have enough energy for the airplane to fly again. Because if a gust comes along, it might make you fly again, and you aren't expecting it, right? So we got to be fully in control. Okay, now she's a tail dragger and she's trying to get away from me, so I gotta stay on the rudders here. Carb heat cold, same flow as I normally do, although we're full stopping. Right, if you got an airplane with flaps and gear, don't touch anything. Get off the runway. Just come to a stop. Get your IQ points back. Then you can think about retracting flaps so that you don't retract the gear instead, right? Okay, looking down center, keeping her straight. I hope you found this helpful. Leave a comment. I don't think I covered everything there is to talk about, so I'm sure we can chime in. But, you know, think about that stuck ratchet analogy. Think about getting nice and slow. Right, if your landings are struggling, just go do stalls. Right, and do stalls without a power in the recovery. Pull back, stall, gently push the nose forward, smoothly pull back into the stall, let the nose forward again. Right, if you want to go watch, I've got a video on stalls, and I do tons of those, and you can watch. And those are super helpful, and you can do a ton of them, and they really help with smoothing out landings sometimes.
Wahoo traffic, Luscombe 903's clear of all runways, Wahoo.
Okay, fuel's off, windows coming open. And let's see, how do we do on sunset? 3 minutes to spare. There we go. Well, hopefully the footage isn't too bad, and enjoyed flying with you guys tonight. Leave a comment. You know, if you're looking for individualized instruction, turn this off. If you're looking for individualized instruction here in Nebraska, the Midwest, let's get in touch. If you want to do virtual ground school, I love to do virtual ground school. get in touch. I'm giving a talk at the Strategic Air Command Museum this weekend on spins, so if you're in the local area, come on out. Love to meet you. And if you want to get in touch, you can use LinkedIn. I'm on there, and we can message through that. But thanks for coming along again, and appreciate it, and fly safe. We'll talk to you next time.